Let's talk about simplifying complex fractions. There are two ways for us to simplify a complex fraction. We'll decide which way to use based on how big the fraction is. First, what it means to be a complex fraction is a fraction within a fraction. So like the one here where we've got one fraction on top, one fraction on bottom. The first way for us to simplify this is to think of it as a big division problem. The fraction bar in the middle here separates it into one fraction on top being divided by one fraction on the bottom. So we can rewrite this as 2/9 divided by 4/3. Well, we know how to do that one. We flip over the one on the back and change to multiplication. The 2 and the 4 can cancel each other out. The 3 and the 9 can cancel each other out. So we would have just ones left on the top and 3 times 2 on the bottom. Looks like when we multiply it together, we would end up with 1/6 there. If you've got just one fraction on the top and one fraction on the bottom, this is the way to go. Think of it as a big division problem. Flip over the one that was on the bottom and change to multiplication and go from there, canceling out from any numerator to any denominator. We can do this by a second way, though, as well. We can also multiply all of the small fractions by a lowest common multiple. For the particular problem we're looking at, 2/9 over 4/3, looking at the small denominators here, the 3 and the 9, what do they both go into? They both will go into 9. So for this one, let's multiply all of the fractions by a lowest common multiple of 9. Up on the top, the 9s are going to cancel out, leaving us just a 2. On the bottom, 3 and 9 will cancel out, leaving 3. 3 times 4 gives me 12 on the bottom. So now 2 over 12, that will reduce to 1/6. We should always reduce fractions. Notice that no matter which way we go, we get 1/6 as our answer. For this problem, when it's just one on top, one on bottom, the first method was the better way to go. But as problems get larger, that second method is going to be the better way for us to do it. For instance, with this one, 1/4 plus 1/2 over 5/8 minus 1/6. First, we need to think about what do all of the small denominators go into. 4, 2, 8, and 6, they all go into 24. So let's multiply everything here, top and bottom, every single fraction by 24. For the first fraction on top, the 4 and the 24 will cancel, leaving a 6. That 6 needs to be multiplied times this 1. On the back, 2 goes into 24 12 times, and that 12 will multiply with this 1. Same thing is going to happen on the bottom. 8 goes into 24 3 times, and we'll multiply 3 times 5. On the back, 6 goes into 24 4 times, and we'll multiply 4 times 1. So now what that ultimately means, 4 into 24 went 6 times, 6 times 1 gives us the 6 that is here. 2 goes into 24 12 times, 12 times 1 is 12, giving me the 12 that is there. 8 goes into 24 3 times, 3 times 5 is 15, and 6 goes into 24 4 times, 4 times -1 gives us this -4 that is here. Combine the things that will. 6 plus 12 is 18 on the top. 15 minus 4 is 11 on the bottom. And now we no longer have fractions within a fraction. We should always get rid of complex fractions by one of the two methods that we've seen. No need to change this into a mixed number. We do always want to see if it will reduce, but we can leave it as this improper fraction. Now, that second method will also work if we have variables involved. For instance, the problem 1 over x plus 1 over x plus 1, all of that over 1 over x minus 1 over x plus 1. First, If there's any factoring to do, we should do that. Then we'll take every different factor the greatest number of times that it's part of one fraction to figure out what our lowest common multiple will be. No factoring needed to happen on this one. It's already in its prime factorization. And notice that x and x plus 1 are different things, so each of those factors need to be part of our common multiple. Nobody is used more than once in a fraction, so the common multiple that we multiply everything by is x times x plus 1. So all four fractions all the way around will get multiplied by x times x plus 1. For the first fraction on top, these x's are going to cancel out, leaving me x plus 1 times 1. For the second fraction on top, the x plus 1's cancel out, and that's going to leave us just an x times 1. On the bottom, the x's cancel out, leaving me x plus 1 times 1. And on the back, the x plus 1's cancel out, leaving me x times negative 1. So now what that ultimately means, on the top, when these x's cancel out, x plus 1 times 1 gives me this x plus 1. On the back of the top, when the x plus 1's cancel out, x times 1 gives me this plus x. On the bottom, the x's cancel out, and x plus 1 times 1 gives me this x plus 1. On the back of the bottom, the x plus 1's cancel out, leaving me x times negative 1, which was negative x. Now let's combine the things that can be combined. On the top, x plus x gives us 2x plus 1. On the bottom, looks like those x's are adding out, and we're left with just a 1 on the bottom. Remember, you don't have to put a 1 on the bottom of a fraction, so we can leave this answer as just 2x plus 1. We should always simplify things as much as we can. Always simplify as far as possible. No need to have a 1 on the bottom of anything. And remember that to get rid of those complex fractions, we multiply everything top and bottom by lowest common multiple.